we have actually talked about a handful of ways of solving quadratic equations. One of them is just straightforward taking the square root of both sides. Okay. And let me just show you an example of that. How would you solve that? Yeah.
Square root of 9.
Uh-huh.
3.
And in fact, it's plus or minus the square root of 9, right? Which makes it plus or minus 3. Yeah? I'm sorry? That's it. That's the answer. If you plug in 3, you get 3 squared. That's 9. If you plug in negative 3 times negative 3, it's positive 9. Those are the two answers. Plus or minus 3? Here? Well, first, those were the steps. From here to here, I took the square root of both sides. Square root of 9 is 3. So it's plus or minus 3. Okay. A problem that looks like this really isn't any harder to solve, because you just take the square root of both sides and you're done. That's the solution. Square root of 7 plus or minus, if you square it, you get 7. That's the answer. Just like when you're trying to solve the answer, when you're trying to get the answer to a problem that looks like this, you're looking for the number you can put in for x that'll give you 5, right? Well, here you're looking for the number you can put in for x that'll give you 7. Or the number you can put in for x that'll give you 9. And in these cases, there are two solutions, plus or minus 3, or plus or minus the square root of 7. Okay? One more. How do you solve this? Josue? How do you solve this? You could take the square root of both sides, and if you do, you'll get x plus 1 is equal to plus or minus the square root of 9. X plus 1 equals plus or minus 3. X is equal to negative 1 plus or minus 3. And so this breaks into two different problems now. X is equal to negative 1 minus 3, or x is equal to negative 1 plus 3. So x is equal to negative 4, or x is equal to 2. What's that? I subtracted 1 from both sides. If I subtract 1 here, and I subtract 1 over here. Now, just to go a little bit further here, take a look. We looked at, when we first started looking at x plus 1 squared, it looked like this, where the area of this was x squared, the area of this was x, the area of this was x, and the area here was 1. Do you remember doing this? So that the area of this rectangle, I'm sorry, the area of this square, was represented by x plus 1 squared. And when you worked it all out, it equaled x squared plus 2x plus 1. Now, if you'll remember, we also did something called completing the square. Right? If I had something like x squared plus 6x, that looks like this. Here's an x squared, and then I have 6 x's, and if I put 3 of them over here, and 3 of them over here, how many ones do I need to complete this? Right? Here's my x squared. Right? This is an L shape, right? But if I wanted to make this into a square, how many ones would I have to stick in here? 9, exactly. That's going to be equal to x plus 3 squared. Why is that interesting? Well, what if I had a problem that looked like this? X squared plus 6x is equal to, let's say 7. Okay? Well, if I could do it, I could take the square root of both sides, but that's not going to help me over here because it's not a perfect square. I can make this a perfect square by adding 9 to both sides, right? That's what we just did. So if I did this, x squared plus 6x plus 9 is equal to 7 plus 9. I'm allowed to do that because I'm just adding the same number to both sides. You with me on this so far? Okay. So what happens? This became x plus 3 squared, right? And this became 16. Well, now I know I can take the square root of both sides. X plus 3 is equal to plus or minus the square root of 16, which is plus or minus 4. Okay. X is equal to negative 3 plus or minus 4, which becomes two different solutions. X is equal to negative 7, or x is equal to positive 1. In a way, I sort of cheated here because I made up a problem where I already knew how to create the perfect square. How would you do this if you didn't? Well, what did we do right here? In order to turn this into a perfect square, what did we do over here? Well, we took this 6 and split it in half so that 3 of them would go here, 3 of them would go here, and then we squared that number. So what does that look like? Well, it looks like this. If we want to complete the square, x squared plus 8x is equal to 9. How would I complete this square? Well, I would take this number here and split it in half and then square it. What does that picture look like? Here's my x squared. Here's my 4 x's. And my other 4 x's over here. Right? There's x squared and 8x. And what I need to fill in here is 4 by 4. I need 16 ones. So this is x squared plus 8x plus 8 over 2 squared. And in order to keep the equation balanced, I have to add the same thing to both sides. Well, the 8 was here, right? I split it in half so that I'd have 4 things here and 4 here, so that I could make a square out of this by filling this in with 4 by 4 ones, 16 ones. Okay? So what happens? This becomes x squared plus 8x plus 16. This becomes 9 plus 16. But we also know that this, because we turned this into a perfect square, this is x plus 4 squared is equal to 25. And now I can take the square root of both sides. I get x plus 4 is equal to plus or minus 5, which means that x is equal to negative 4 plus or minus 5, and x is equal to either negative 9 or positive 1. Now, let's just take this for a second. If these are the right answers, then I should be able to plug it in here and get the right solution. So, for example, here's x squared plus 8x equals 9. If I plug in 1, what happens? This is 1 squared plus 8 times 1 is equal to 9. That works. And what happens if I plug in negative 9? Negative 9 squared plus 8 times negative 9 equals, this is 81, this is minus 72, that equals 9, so that works too. So these two right here are the solutions to this. This process is called completing the square. Of course, sometimes you don't have squares. Sometimes you have rectangles. X squared plus 6x plus 8. Okay, what does that look like? Well, here's your x squared. Can anybody factor this? Yeah.
X plus 2 and x plus 4.
That's exactly right. X plus 2 and x plus 4. And what that looks like is x plus 2 over here, and then x plus 4 over here, and then what fits in here is 8 ones. 1, 2, 3, 4, right? 1, 2, 3, 4, 5, 6, 7, 8. Now that's not a square, that's a rectangle. But once again, the area of this rectangle is represented by this equation. By this equation. Okay? This equation is the area of this rectangle. And these are the dimensions of the rectangle. X plus 2 over here and x plus 4 over here. What does it mean to have a rectangle with an area of 0? It's a bizarre thought, isn't it? I mean, no matter how tiny your rectangle is, there's some area there, right? How can I make there be no area, even if I made it even tinier? There's still area in there. How can I make that be no area at all? What's that? No, if I just had this be one straight line, so that there was just one dimension this way, but no width. If I had this as a rectangle, and I wanted to squeeze it to make this area 0, I'd have to just keep moving this up until I actually turned it into a straight line. And then it would have a 0 area. Or I could do it the other way. I could say I'll just move this way. Smaller and 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 smaller until I just have this one straight line. Then there's no area at all. So what does that mean? That means if I took this and factored it, now I'm representing this area as the product of the two sides. And what we just got finished saying is if I squeeze one of the sides down to 0, either this one or this one, then the area of the whole thing will be 0. So what happens here? X is equal to negative 2, or x is equal to negative 4, and either one of those will make this true. If you remember, we did this, and we called this, in algebra, we call this the zero product property. If you have two numbers and you multiply them together and they equal 0, then that means one of them has to equal 0. Remember that? So what is that really talking about? That's sort of the numerical way of talking about squeezing a rectangle down to the point where its area is 0. all of this is factoring. Okay. Now let's just take this one step further. Okay. Remember we said that if you had an equation that looked like this, this is a quadratic equation in standard form, right? Now, if I take this, I can divide all the way through by a, and I would get x squared plus b over a times x plus c over a is equal to 0. Everybody understand what I just did? Okay. Divided this by a, and this by a, and this by a, and this by a. Okay? This way? All right. Now, I'm going to subtract this from both sides. Watch what happens here. X squared plus b over a times x, and put it over here as negative c over a. Does everybody understand what I did there? I just took this and subtracted it from both sides. C over a here, negative c over a here. Now, let's do a little bit of magic here. What if I tried to complete this square? What would I have to do? Well, I would have to take this number here, divide it by 2, and square it. And on this side, I'd have to do the same thing. I'd have to plus b over 2a and square it. So basically what I just did was what we were talking about a moment ago, where you complete the square by taking this number, divide it in half, and then square it, and add it over here, and you can add it to both sides. So what happens? On this side, you got to do a little bit of arithmetic. Minus c over a plus b squared over 4a squared. It's just squaring this. And then, if I wanted to find a common denominator for the two of these, I'd have to multiply the top and bottom of this by 4a. And then I would have b squared minus 4ac over 4a squared. Okay? That's how I got from here to here to here. And on this side, because I made a perfect square out of it, that becomes x plus b over 2a squared. Okay, one last little piece of magic here. What if we take the square root of both sides? That'll turn this into x plus b over 2a, and this into plus or minus the square root of b squared minus 4ac over 4a squared. And when you work this out, this is plus or minus the square root of b squared minus 4ac, right, over the square root of 4a squared. And if I take the square root of 4a squared, I have 2a over here. Over here, I still have x plus b over 2a, x plus b over 2a. And if I subtract b over 2a from both sides, I get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a, which I can combine to make x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Does that sound familiar? It is. And you get the quadratic formula by starting with the standard form of the equation, completing the square, going through all of this work to get to here. And now here's where the law of syllogism comes in handy. Do you remember the law of syllogism from the reasoning standard? Well, take a look at this. We started with this and we said, if this is true, then this is true. And if this is true, then this is true. And if this is true, then this is true. And if this is true, then this is true. And if this is true, then this is true. And if this is true, then this is true. Well, the law of syllogism says I can do this. And I can say, if this is true, then this is true. So it's not that I did this for nothing. I did this to show that if you have an equation in this form, then you can solve for x by using this equation. That means we have taken the square root of both sides, we have completing the square, we have factoring, and we have the quadratic formula. Sometimes this works well, sometimes this works well, sometimes this works well. This is sort of the generic case. This will always work. If you guys were computers or robots, I would just plug this in, I would just tell you this, and I would say, from now on, don't think of anything else, just think of this. But the thing is, you're not. And because you're not, it's better if you know all four methods, because doing the quadratic formula involves an awful lot of arithmetic that opens the door for you to make mistakes. I'm going to give you 4 problems here that will show you exactly what I'm talking about. Here's one. X squared plus 3, or k squared plus 3k minus 40 equals 0. Okay? I could jump right in and say negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 40 all over 2 times 1. And then do that arithmetic and see what happens. But first, let's just ask, can we factor this? K. Well, is it if I do that, k minus 8 and k plus 5, will that work? Right. This won't work, right? Because negative 8 times 5 will give me negative 40, but when I add them together, I'll get negative 3, and I want positive 3. So it's got to be k plus 8 times k minus 5. These two are equal, right? So this is an equivalent equation. And now I can use the zero product property to say k plus 8 has to equal 0, or k minus 5 has to equal 0, which means k is equal to negative 8, or k is equal to plus 5. And I'm done. I don't know if it's easier or not easier, but if you have to do this, k equals negative 3 plus or minus the square root of 3 squared minus 4 times a times c all over 2a. You'll still get these answers, but you got a lot of arithmetic to do, and you're just liable to get yourself tripped up. Okay? So if you can remember that factoring might work, that helps. How about this? X plus 3 quantity squared minus 4 equals 12. What can I do here? You mean add 4 to both sides? I can do that. If I do, I'll get x plus 3 quantity squared is equal to 16. Now what? Take the square root of both sides. X plus 3 is equal to plus or minus the square root of 16. x plus 3 equals plus or minus 4. X is equal to negative 3 plus or minus 4. And that comes up with two different solutions. X is equal to minus 7, or x is equal to 1. Could you use the quadratic formula for this? Yes, but not right away. If you wanted to use the quadratic formula for this, you would have to square this, then subtract this, and then set it up so it was equal to 0. So this would look like x squared plus 6x plus 9 minus 4 equals 12. X squared plus 6x plus 5 equals 12. X squared plus 6x minus 7 equals 0. And now you could use the quadratic formula. Negative 6 plus or minus the square root of 6 squared minus 4 times 1 times negative 7 all over 2 times 1. A lot of extra work. Whereas if you remember that you can do it this way, your life's a little easier. Take a look at this. X squared minus 6x is equal to 73. Well, I could subtract 73 from both sides and then use the quadratic formula. But it might be easier to say x squared minus 6x plus negative 6 over 2 squared. And add that to both sides. Why? Because now I'm completing the square. This is x squared minus 6x plus 9 is equal to 73 plus 9. This, now that it's a perfect square, looks like this. X minus 3 squared. This is 82. Take the square root of both sides. X minus 3 equals square root of 82, plus or minus. X is equal to 3 plus or minus the square root of 82. And we're done, because there's nothing more you can do with that. Here, 4x squared is equal to negative 10x plus 36. You tell me what happens. You can take this equation and put it into standard form. And then once it's in standard form, you can actually reduce it. Right? You can divide each of the terms by 2. So you get 2x squared plus 5x minus 18 equals 0. And at that point, you've got a couple of choices. You could try to complete the square, or you could try to factor it.
I could make a table of values here. I could find something that would multiply to equal or negative.
If you can't find anything, then this is a good way to go. Did anybody find something here? Okay, yeah.
I got 2x plus 9 times x minus 2.
Oh, yep. That works, doesn't it? 9 times negative 2 is negative 18. 9 times x is 9x. Minus 2 times 2x is minus 4. Put them together, you get 5x. This works. So that now 2x plus 9 has to equal 0, or x minus 2 has to equal 0, which means x is equal to negative 9 over 2, or x is equal to 2. That would be this solution right here. What happens over here? Well, let's do some arithmetic. Same solutions that we got here, we wind up with down here. Right? The method you use to solve these equations doesn't really matter. What matters is getting the solution and then plugging it back in to make sure that it works.